Busy with a introduction to automotive computers lesson. We are revising our training platform, and the idea behind it is, number one, for this section of the lesson, I want to compare two computers for you guys. I want to compare the structure of an older ECU and the structure of a newer ECU, as well as a normal computer, showing you why you need to know. Move. You can take these chairs away. Why you need to understand these differences. Okay. Now, many of you don't really want to learn about computers, and the secret to success in this industry is understanding that any control unit in a vehicle, whether it's an engine control unit, whether it's a key, or whether it is a ECU, gearbox controller, those are all microcomputers. They are computers. They don't have computers. They don't have keyboards, mice, or something in that sense, but they are still computers, right? If we look at a standard desktop computer, what is the same? What do you think? What is the same in a desktop computer and this ECU? Show me one thing that is the same. Okay, all computers will generate heat, right? The processes, the heat in this box. What does this box do? The basic functions of this box. What the basic function of the box? What is the basic function of this box?
It's to process the data.
Yeah, process the data, but what is the basic function? When I say the basic job, what is the basic job of this box? Once the processing is complete, what is the basic function? Remember, once the processing is complete, the basic function will take place. Remember, this is it's going to turn the injectors on and off. Remember, guys, everything we want to do, we want to try to keep it as simple as possible. So in the simplest explanation is that this thing turns the injectors or the unit pumps, the solenoids on those unit pumps, it turns them on and off. Now, what it uses, it will use MOSFETs to turn those pumps on and off. And what is one, as an auto electrician, what is one thing you can tell us about those solenoids? They look quite big to me. So they will throw a lot of current, although either need a lot of voltage, high voltage to turn them on and off. So that there will be created by the engine control unit. And the engine control unit, during that process, what is going to happen? It will become hot. It will generate a lot of heat. So when it becomes hot, what does the ECU need to do? It needs to be cooled. It needs to get rid of that heat. So if we look at a normal computer, normal PC, it has during processing, the microprocessor will get very hot. Like anything that processes data will get hot. If it had a high capacity graphics card, it will have these cooling fins. So this PC here has these cooling fins. It also has a fan on the other side. And that fan will force air through here that will cool the PC down. Okay. So something it will have in common with this MR. This MR, if we look at the construction of this MR, this whole MR is an aluminium heatsink. And where is this MR mounted? This one is on the engine. And it also has this here. this here, there is fluid that is pumped through here that will cool the control unit down. Let us pump through here. Yeah. So I think maybe it fulfills two roles there. What do you think? So it will warm the diesel up as well. So if it's pumping the diesel through here, it will warm that diesel up too. So then the engine control, it will be easier to ignite that diesel. I'm not sure if that is the purpose of it.
Yeah, but why should it be mounted there? Should
Right.
always on here.
And we're still using diesel.
Maybe in colder climates, it will also help to warm up the diesel before it's injected into the engine. Look, there must be a reason why they have done it. But I think the primary reason would be, if you look there, it's made in such a way so it sits flush on the ECU and it's able to extract that heat away from the ECU. Now, if we look at here, if we look at this PC here, if we look deeper now, we're going to find more things that match, more things that are in this one and in this one here. So the next item we'll look at is that there is the RAM. Right? RAM is volatile memory. Volatile memory is something that when power is removed from it, it is gone. Right? Now, that there is our RAM chip in this ECU. So what I'm going to do is, when we update that there, I am going to put a exploded diagram of this PC, and I'll use that PC as the comparison PC. Now, the reason why I also want you guys to build PCs is I want you to see what happens when it fails. So when I'm gone here, I've got some computers here that you guys are going to load software on. So you're going to take the RAM out, switch it on, see what happens when you take the RAM out. Put the RAM back in, see what happens. All those things are things that are going to lead you to understand how to fix these computers. Because besides that, sometimes you, like for example in this one here, we had an EPROM tampering, non-volatile memory tamper area fault in this control unit here. So when it says non-volatile memory, it is referring to the EPROM memory, because the EPROM memory is non-volatile. It's NVRAM. Because when you remove power from there, it still keeps the memory in. Okay. Now, you see what if this PC fails to start up when the RAM is removed, what will happen to this PC if the RAM dies? Or if the RAM doesn't get power? It's not going to work. It's not going to start. Now, our next item that we're going to look at, we should have actually started by power. Now, when it comes to this PC, if you look at this PC here, the mistake that's in this thing modified my manual and it's converted my manual to its version of the manual. But that is incorrect. So I'm revising it. If we look at the power supply is where we start. So I want you to start off with a power supply. What is this power? Why would we require a power supply in a computer? Gabriel? Why would we require a power supply?
Separate one.
So we plug it into the wall, doesn't that supply power? Yes, to convert the power. Because the power coming from a wall outlet will be too high and it will be AC. So inside our computer, say computer 1, computer 2 requires different voltages. So here we have our power supply that creates our individual voltages required by our memory, required by our processor, and required by our peripherals. Our peripherals will be things like your CD-ROM. So your CD-ROM has motors and stuff in it, and that CD-ROM will run off the 12 volt line. So this will step down that power, it will then convert it to DC, and then once it's converted to DC, it will convert it to the correct voltages that is required. Now, we need to focus on that section too, because when we do our electronics lesson, I also have some inverters I'm going to get Wanda to look at as well. Because if you look at electrical vehicles are stepping things down, then they're stepping things up again. And then they're converting again from DC to AC. So which is why it is important to understand how that process takes place here. Because this knowledge here you are going to apply again in EVs. When you move on to EVs, the same platform that we are building here now, the same foundation that we are building here now, is going to be applied there. So everything is important. Understand, guys?
Yes.
So now, what is our next thing we have in common here? So there we have our processor. Over there we have our EPROM memory. Now, the non-volatile memory in your PC is your what? What is the non-volatile memory in the PC, guys?
CPU. CPU.
Does the CPU save information?
The ROM.
ROM is also non-volatile memory, but ROM is read-only memory. So a CD-ROM would be read. Look, you do get CDs that you can write, right? So you get CD-RW, that is rewritable CDs, but that is also memory, ROM, read-only memory. If you look at your hard drive, when you take power off your hard drive, does the information disappear? No. So the hard drive will be like our EPROM. Right? So where you want to keep things permanently, you will keep it on the hard drive. Like your operating system is stored on the hard drive. These things are important when we move on to like comparing EPROM and flash memory in ECUs. Remember when we started reading controllers, we had the option to read EPROM and we had the option to read flash, right? So we need to differentiate between that two, but we're going to get there. And part of getting there is going on this journey with these computers, right? Now, that is also memory, right? It is an EPROM with one E. We haven't done EPROMs yet, we're going to do them. We have a complete lesson that is just dedicated to EPROM, so we will do that next. After you guys have done this, we will do the EPROM lesson. We'll do that problem Monday. And now, on this particular chap here, this is it's very old memory, right? And something that you guys also need to, whenever we complete the lesson, I'm going to tell you guys to start reading data sheets. We had some students here who were very apprehensive about data sheets. They didn't want to read data sheets. Most of the guys just want to jump to the repair section. Data sheets is what helps you repair. Data sheets, it sparks things in your mind. Sometimes we will see common failures. I've experienced a common failure in some of these boxes. We are finding a common failure where data is lost in this controller here, in this flash memory here. But if you look at it, I think the data retention in it is 40 years. But that is what the manuals, what they were predicting when they manufactured this chips here. They said maybe this thing will have so many reads and writes. But this one here can't write. This is an EPROM with one E. It's not an EPROM with two E. EPROM with two E's are electrically erasable. The method we use to erase this one is we put a UV light there. We'll show you guys how to erase them as well. We use a UV eraser. Okay. Now, when we look at later model ECUs will not be microprocessor based. What will they be? They will be microcontroller based, right? Now, microcontroller based ECUs will have everything in one chip. Everything will be in one chip. Sometimes it's good for us, and sometimes it is bad for us. And we find that many new guys, they will work on microcontroller-based ECUs and they will look for EPROMs because they've become used to swapping EPROMs. But this one here has got built-in EPROM. And also it's something to remember, guys, even though some ECUs have EPROMs, you cannot just swap EPROMs. Some of those EPROMs will contain checksums. Okay, thank you, Zina.